In this video, we're going to continue to look at the rules of derivative. And now we're going to look at the product rule. The product rule says, let's say u and v are differentiable functions, and they're connected by product. So derivative of uv will be u times the derivative of v respect to x plus v times derivative of u respect to x. So in other words, you could rewrite it like this. Derivative of uv is u times v prime plus v times u prime. So let's say you have f of x equals quantity x squared plus 1 times the quantity x cubed minus 2. So you could say this is u, and you could call that v. They're connected by, these two functions are connected by multiple product. So if you want to take the derivative, f prime of x, that's going to be u, which is x squared plus 1 times the derivative of v, which is 3x squared, plus v, which is x cubed minus 2, times the derivative of u respect to x, which is 2x. Now you could clean it up using algebra 2. 3x to the fourth plus 3x squared plus 2x to the fourth minus 4x. You add up the like terms, you're going to get 5x to the fourth plus 3x squared minus 4x. Now, instead of using product rule, you could also multiply this out before you take the derivative. You get x to the fifth minus 2x squared plus x cubed minus 2. Now let's see what happens when you take the derivative. Of course, it's better to put x cubed before negative 2x squared. What happens when you take the derivative? You get 5x to the fourth. What's the derivative of x cubed? Plus 3x squared. What's the derivative of negative 2x squared? That's negative 4x. And of course, derivative of negative 2 is 0. So you end up getting the same answer. But you got to know the product rule because sometimes it's very difficult to multiply out the terms. So make sure you know the product rule. Next, we have a quotient rule. You want to take the derivative of u over v, where v is not equal to 0, and they're both differentiable. So when you take the derivative of u over v, it's going to be v squared on the bottom. And then on the top, you are going to have v times the derivative of u minus u times the derivative of v. In other words, whenever you take the derivative of u over v, that will be equal to denominator square on the bottom. Denominator square, and on the top is going to be denominator times the derivative of numerator minus numerator times the derivative of denominator. You could think of it like that. So let's say you have f of x equals x squared minus 1 over x squared plus 1. So our u is x squared minus 1, and our v is x squared plus 1. So how would you find the derivative of this, f prime of x? Well, it's going to be first, it's going to be the denominator square, v squared, so quantity x squared plus 1 squared. Now what about on the top? It's going to be denominator v x squared plus 1 times the derivative of the numerator u, which is 2x. Then minus the numerator, which is u, x squared minus 1, times the derivative of the denominator, v, so 2x. Now all we got to do is clean this up. So you get 2x cubed plus 2x. I distributed 2x. And I got to distribute the 2x over here. Now don't forget there's a minus. There's a common mistake. Don't forget to distribute the negative later. So 2x cubed minus 2x all over quantity x squared plus 1. So you'll get 2x cubed plus 2x minus 2x cubed plus 2x all over quantity x squared plus 1 square. 2x cubes cancel out, so you end up getting 4x over quantity x squared plus 1 squared. So this is the f prime of x. Now, they're saying that let y equals uv be the product of functions uv, and they want us to find y prime of 2 by given information. So in order to find y prime of 2, first, we know that y is u times v. So what is y prime? Y prime will be, using the product rule, you get u times v prime plus v times u prime. Now our goal is to find y prime of 2. So this will be same thing here, u of 2, v prime of 2, plus v of 2, u prime of 2. Now all these informations are given over here. What is u of 2? That's 3. What is v prime of 2? That is 2. What is v of 2? That's 1. And finally, u prime of 2 is negative 4. And you clean this up, you get 6 minus 4, which is 2. So therefore, y prime of 2 is 2. Now we have a power rule for negative integer, power of x. So let's say you got derivative of x to the n, where n is a negative integer, and x is not equal to 0. Then it is the same thing as n times x to the n minus 1. So let's say you got f of x equals 1 over x cubed. Some of you might want to use a quotient rule, saying that u is 1 and v is x cubed. You could do that. You could say that f prime of x is denominator squared, which is x to the 6, and the denominator times the derivative of numerator, which is 0, minus numerator times the derivative of denominator, which is 3x squared. You end up getting 0 times x cubed is 0, so you get negative 3x squared over x to the 6, and then you simplify, you get negative 3 over x to the 4th. Okay, that's using the quotient rule. However, you could use the rule 7 for this problem. First, I'll rewrite it. F of x equals x to the negative 3rd. Now, apply the power rule. So what is the derivative? Well, it's going to be negative 3 x to the negative 3 minus 1, which is negative 4. And when you simplify, what do you get? Well, you could make that into a positive exponent. Negative 3 stays on top. You get x to the 4. You get the same answer, but obviously this method is much quicker and faster. And let's take a look at this example. Find an equation for the line tangent to the curve. So basically they want us to find the equation of the tangent line to this curve at the point 1, 2, and support your answer graphically. So in order to find the tangent line of this curve, we first need to find the slope of a tangent line to this curve at 1, 2. So we'll eventually use y minus y1 equals m times x minus x1, the point slope form, to find the equation of the tangent line. Now, let's find the derivative, y prime. You could use the quotient rule. However, let's simplify this. So y is going to be, I'm going to separate them, x squared over x plus, x squared over 2x plus 3 over 2x. And then y is going to be 1 over 2x plus 3 over 2x to the negative 1. Now make sure, if possible, change your original curve or function in a simple form so that you could apply power rule. Now let's take the derivative. Applying the power rule, the exponent here is 1. 1 times 1 over 2 is 1 over 2. And 1 minus 1 is 0, and x to 0 is 1. So you just end up getting 1 over 2. Now what about over here? Negative 1 times 3 over 2 is negative 3 over 2. X to the minus 1, negative 2. So you end up getting 1 over 2 minus 3 over 2x squared. Okay, that is a derivative of y prime. This is y prime. So what is a slope at 1, 2? Well, you got to put 1 for x, you end up getting 1 over 2 minus 3 over 2, which is negative 1. So slope at 1, 2 will be negative 1. Now we have a slope, and what is the point? They gave to us 1, 2. So let's plug in over here. You get 1 y minus 2 equals negative 1 times x minus 1. And you could leave it like this, or if you want to go further, it will be y equals negative x minus 3. But this is good enough for the AP exam. I'm sorry, this should be positive 3. So it's y equals negative x plus 3. So now how would you check graphically? Well, you would graph this original curve and then graph the tangent line and see if it makes sense. That's how, you guys know how to use a graphing calculator, so you could do that on your own. Now we're going to look at our final example, finding higher order derivatives. Believe it or not, there is more than first derivative. We're going to talk about first, second, third, fourth, and so forth. So given that y equals x cubed minus 5x squared plus 2, they want us to find the first 4 derivatives. So what is the first derivative, y prime? That's going to be 3x squared minus 10x, and then plus 0. What's our second derivative? Y double prime. So y double prime is a derivative of y prime, which will be 6x minus 10. What about the third derivative? Y triple prime, which is 6. Now, y to the fourth derivative. Now, we don't want to write prime 4 times, so after y triple prime, we just write y parentheses 4. And then what is a derivative of 6? 0. Now, what will be the fifth derivative? Y to the fifth derivative. That's going to be 0. And y to the sixth derivative? Also 0. And so forth. You get the idea. Now, besides y prime, you know that we also use dy over dx, derivative of y with respect to x. These are like first derivative. Now, what will be the notation for second derivative using dy over dx? That will be derivative of dy over dx, which is d square y over dx squared. So this is a notation for second derivative. What about the third derivative? D over derivative of d square y over dx squared. Well, multiplying this out, you're going to get d cubed y over dx to the third. So you get the idea? We have different notations for first derivative, second derivative, and third derivative. And a lot of time we also use the f of x, right? F of x is y. So what is the derivative of f of x? F prime of x. F double prime of x. And so forth. When you get to fourth derivative, you have to use a parentheses. So we have a different notation for higher order derivatives.